Here's the definition of a limit from Calc 1. Some students have a problem really grasping the idea behind this definition. And there's two reasons that contribute to that, I believe. One is this notation is not very helpful. Secondly, is this definition involves the idea of convergence, but convergence is not explicitly mentioned. In the calculus textbook that I'm using now, on page 83, there's this comment. And this is another way to write the same idea. And we can go a step further. When we say this expresses the same idea. F of x converges to L as x converges to A. We could even write it like this. If x converges to A, then f of x converges to L. But what is convergence? What do we mean by convergence? Well, we've seen something like convergence ever since grade school. In grade school, I learned to express the fraction 1/4. I divide 4 into 1 and I get 0.25. To express the fraction 1/3 as a decimal, I divide 3 into 1 and I get an unending series of digits. It will be helpful in understanding convergence to think of x in a new way. We'll think of x as moving. First it's 0.3, then it's 0.33, then it's 0.333. And we say that this x, this moving x, converges to 1/3. Now how can we express that more mathematically? Well, first of all, let me point out that this is a new idea of an unknown. Previously, we've seen x represent one number, as in x plus 5 equals 12, or two numbers, x squared equals 9, or an infinity of numbers, x is greater than 8. But this is a new idea of an unknown, a moving unknown. X is moving. So, what do we mean when we say x converges to 1/3? Well, we mean that x is getting closer and closer to 1/3. Now, mathematically, we can say that the distance between x and 1/3 is getting smaller and smaller. Now, to express distance, we take the absolute value of a minus b to find the distance between any two real numbers. For instance, the distance between -1 and 5, you can write it as -1 minus 5, or you can write it as 5 minus -1. The order doesn't matter. You get the same distance of 6. So, we say that x converges to 1/3 if the distance between x and 1/3 is getting smaller and smaller. But the distance between x and 1 is also getting smaller and smaller, but we do not say that x converges to 1. So x converges to 1/3 because the distance is getting smaller and smaller than any positive number we care to name. So in other words, if we say 10 to the -50th, eventually this distance is less than 10 to the -50th. As soon as we've added enough 3's. So, x converges to 1/3. The definition, mathematically, would be that the distance between x and 1/3 eventually, for a moving x, eventually gets smaller than any positive number we can name. This can be 10 to the -50th, it can be 10 to the -100, whatever number, eventually x will move within that distance of 1/3. So there we go. This is what convergence is. Now once you grasp this, understanding the limit is easy. So the limit definition has this. It says that x, the distance between x and a, I've been using 1/3, is eventually less than any positive number. It also has this. It's greater than 0. The idea is x is moving closer and closer to a, but we don't allow it to equal a. Now that's of interest when we learn the definition of the derivative. But once we understand this, the limit idea is easy. If we use this notation, if we are told that x converges to a, x gets closer and closer to some number, and if we're given a function, then the limit says, what does that function converge to? So for instance, if x converges to 1/3 and we're given this function, f of x is 2x, then it's obvious that f of x is getting closer and closer to 2/3 as x gets closer to 1/3. And so there's the idea, and it could be written like this. Similarly, if x is converging to 1/3 and we're given the function x squared, well, that function is getting closer and closer to 1/9 as x gets closer and closer to 1/3. So we could write this. And one more. If x is getting closer to 1/3, and h of x, the function h of x is x plus 4, then h of x is converging to 4 1/3. And so, this notation and this are saying the same thing. So here's the limit definition. And you'll see how it involves the idea of convergence twice. Here, x is converging to a, and here f of x is getting closer and closer, i.e. converging to L. So we could really write this as an alternate definition of the limit. We'd have to include this sentence if x is a function defined on an interval. However, to be really exact, we'd write this to say that x is not going to equal a, but it's going to converge closer and closer to a. That would take into consideration this fact. I haven't seen this in the literature, but conceptually, that's what the limit is. X is getting closer and closer to a, but we're not letting x equal a, or we don't care what happens when x equals a. I'll get to that in a minute. But if x converges to a and the function converges to L, we write this. Now, one final point. Here is the function 2x. And as we saw before, x gets closer and closer to 1/3. The function's value is going to get closer and closer to 2/3. The important thing to remember is because we don't care what happens when x equals 1/3, that this function here says f of x equals 2x except when x equals 1/3, then the function equals 1. Nonetheless, the limit is still 2/3 because as x gets closer and closer to 1/3, this function's value gets closer and closer to 2/3. Therefore, this is still the limit. I hope that was helpful. Thanks for listening.